All right, so today we're going to be talking about Chapter 7, Lesson 1. It's all about classifying angles. So when we start looking at angles, one of the things we start looking at is how many degrees are inside of an angle. So these first couple, we're going to be talking about how they are going to be looking. So an acute angle. This is an angle less than 90 degrees. Those are acute angles. Obtuse angles are angles more than 90 but less than 180. So like 120 would be an obtuse angle. A right angle is an angle exactly 90 degrees. The symbol for this one is going to be looking like this. So if these are the angles, I draw a little box down there. A straight angle is an angle that is exactly 180 degrees. And generally the way that we show that is like that. So if we go back up to acute, an acute angle would look something like this. An obtuse angle would look something similar to that. Now, these two words here, vertical and adjacent, they're really going to be talking about pairs of angles. So these are pairs of angles. And something that's really, really important when it comes to vertical angles is they share a vertex or the corner, but not a side. So this is what happens when we have two lines that cross. These two angles here, the vertex or the corner, they share that, but they don't share a side, because this angle is formed by going down and then up. This angle is formed by going up and then down. They meet right here on the corner, but they never overlap a side. Important thing here, these angles are congruent. And that means they're equal. But we like the word congruent in math. Now, when we have adjacent angles, these are also pairs of angles. Very similarly to vertical angles, they share a vertex or a corner and a side. So again, if we look at the same diagram that we had for vertical, these two would be adjacent angles, because they share this vertex. This angle goes down and up. This angle goes up and still up. So they share this vertex and they share this side. And that's what calls them adjacent angles. Careful though, these are not always congruent. They can be, but that's not something that's very special about adjacent angles. So, first thing I want to do is we're going to talk about naming and identifying the following angle. So in this case, we have an angle here. This appears to be an obtuse angle or an acute angle. But there are three different ways to name it. One of the ways is by letters. And there are actually two different ways that we can look at it, going from left, down, and up to the right, or from the right, down, and then up to the left. So this symbol right here, this here means angle. So the way we name angles by letters is we start at one of the sides, either F or H. We're going to write that down. We always travel through the vertex, so that'd be G. And then we go up to our endpoint, which is H. So this first letter is the start. The middle letter is always the vertex. And this last letter is the end. So we could also reverse this too. We could start at H, still go through G because that is the vertex, and end at F. Generally, we like to go alphabetical, but it doesn't always have to be that way. Another way that we could do it is by simply using the vertex. And in this case, the vertex is G. So we're going to do angle sign and just the letter G. This is going to be used if there's only one angle. So only one angle. The letters are going to be used if more than one angle could be letter G, where letter G is the vertex of more than one angle. So this one is going to be many angles with vertex G. And we'll look at that in a little bit here too. The last one, though, is by a number. And sometimes each of these angles does have a number associated with them. So here's the number 2, so we could call this angle 2. Alright, so let's look at another example here. We want to identify a pair of vertical angles and a pair of adjacent angles in this diagram. So vertical angles, let's label this as 1. Vertical angles, again, are angles that share a vertex. The only vertex that we have is right here, but they don't share a side. So if we pick any of these 4 angles, let's just pick angle 4 first. Angle 1 is its vertical angle because angle 4 is formed by these 2 lines here, going from this line down to the vertex and up. Angle 1 goes up to the vertex and down. My pen never overlaps any of these sides. So we could say angle 4 and angle 1. We could also say angle 3 and angle 5. Notice how they come in pairs. That's very important. Now, these are vertical angles because they share a vertex, but not a side. Adjacent angles, there are many of these. There's a lot of them. But we can say just angle 4 and angle 5. We could say 3 and 4. We could say 3 and 1. Or you could say 1 and 5. But the reason why is they share a vertex and a side. Alright, so let's talk about finding a missing measure. So something to keep in mind would be vertical angles are congruent. And remember, that means equal. So if we look at example 3 here, it says, what is the value of x? And then it says to justify. So these 2 angles here, they're vertical angles. Here's the vertex. They're formed by 2 intersecting lines. They don't share a side, which means that they have to be equal to each other or congruent. So now we have a one-step equation that deals with dividing to solve. So I'm going to divide both sides by 2 after I draw my line down the middle. 120 divided by 2 is 60. 2x divided by x simplifies to just x. So x is 60. The reason I know that is because the 120 degree angle and the 2x degree angle are vertical. And that's how I know that we can simply set them equal to each other. All right, that is the end of lesson 1. If you have any questions, please let me know.